So we're going to factor trinomials, where the only difference now is we're going to actually have a number in front of our x squared. So all the trinomials that we've been factoring, the x squared has just been by itself. It's just been 1x squared. But now we're actually going to have a number other than 1 in front of our x squared. So we're going to have to pay specific attention to there's going to actually be a coefficient here. This is going to end up being a number, which is going to add in a couple more steps for us when we're factoring. Because now we have to consider that number when we're creating our two sets of parentheses. So the first thing we're going to have to do, instead of just looking for factors of C that add to B, we're going to have to look for factors of A times C. So the first thing we'll have to do for all these problems is multiply that coefficient and the constant together and then look for factors of that number. So for the first step, we're going to multiply A and C. And A just represents the number in front of x squared. C just represents our constant all the way at the end. We're going to multiply them together, and then we're going to look for factors of that number that add to B. Look for factors of A times C that add to B. So same kind of idea as before, looking for all the factors, seeing which ones add up to be that middle coefficient. But since we multiplied by A in the beginning to get the factors, once we pick out those two factors, we're going to have to divide the two factors by A to undo that multiplication we did in the beginning. So after we look for the factors and we find them, we're going to write our two sets of parentheses. Just like we did last time. But at this point, before we can finish the problem, we've also got to divide our factors by A. So since we multiplied in the beginning, to undo that multiplication step, we've got to divide. Divide both factors by A. And then we're going to simplify those fractions. And if we can't simplify the fraction, we're going to take the denominator and we're going to bring it up in front of the x, which sounds like I'm talking straight crazy right now, but when I show you with numbers, it'll make a whole lot more sense. So if it's possible, if we end up with something like 6 over 2, we'd simplify it to just get 3. But if we end up with like 6 over 5, which we can't simplify, right? 5 doesn't divide 6. We're going to take that 5 and bring it up to be the coefficient of the x so that we don't have ugly fractions in our parentheses. So we're going to say, simplify or bring the bottom up. So there's a lot of different ways that you can factor trinomials like this that have a variable in front of the x, or have a coefficient in front of the x squared. This is like, I actually kind of came across this from talking to another teacher after I started teaching math, and I think it's pretty cool, and it's the easiest way to give you guys like a straightforward set of steps that works for every single problem. Like the way I was taught in school, it was like, oh, kind of just guess and check and pick out pick out possible factors and then FOIL it and see if it worked, which is like could take a whole lot of time. This is like a really straightforward way that helps you do every single problem, and you can do every single problem the same way with these steps. So let's see it with some actual numbers so this makes a little bit more sense. So now we're going to factor 4x squared plus 13x plus 3. So looks very similar to even the do now questions. The only difference is we've got that 4 out in front. So the very first thing I'm going to do is I'm going to take 4 times 3 and look for factors of 4 times 3. So off to the side, I say, okay, 4 times 3 gives me 12. So now I want factors of 12. So I know I've got 1 and 12. I've got 2 and 6. And I know I have 3 and 4 because that's how I even got to 12, right? I multiplied 4 and 3 to begin with. So I've got all these factors. Now I just need to do the same thing I was doing before. I look at my list of factors and I say, okay, since my middle coefficient, my coefficient in front of the x is 13, which one of my factors adds up to be 13? And I see that 1 plus 12 is going to give me 13. So when I write my parentheses, I'm going to do exactly like I was before. I'm going to split up my x into both sets of parentheses. And I'm going to say, okay, I have a 1 and I have a 12. They were both positive, so they both get a plus sign. But since I multiplied by 4 to get those factors, I need to divide by 4 in order to undo that extra step that I kind of threw in there. So I'm going to divide both of them by the 4. And I'm dividing by 4 because that's this number right out in front of the x squared. I'm always going to use that number out in front of the x squared. If I can simplify it, I'm just going to simplify it to a whole number. If I can't, that's where I'm going to take that bottom and bring it up. So since 1/4 I can't simplify, I'm literally going to take the 4 and bring it up in front. And I can do that because basically what I'm doing is I'm multiplying both of those terms by 4 in order to cancel out the denominator. When I multiply by 4, I get a 4x plus 1. So my first set of parentheses is 4x plus 1. My second set of parentheses, x plus 12 over 4, or 12 divided by 4 just gives us 3, right? We can simplify that one. So if we can simplify it, we do. If not, we bring the bottom up. And that is our final answer. If we wanted to check ourselves, we could FOIL it and make sure we got back to the same problem that they gave us to start. But not too bad, right? Try another one. Let's factor 3x squared minus 7x plus 2. So again, now we want factors of 3 and positive 2. So we do 3 times 2. 3 times 2 gives us 6. So now we need numbers that multiply to positive 6 but add to negative 7. So we know that means that we need negative factors. They both have to be negative since they're multiplying to be a positive, but they have to be negative since they need to add to be a negative. So we could have negative 1 and negative 6, or negative 2 at -3. And then we ask ourselves which ones we're going to add to be -7. We're going to use -1 and -6, right? So I go in and I write my two sets of parentheses, my x -1 and x -6. So that'll add to be -7. And then I have to divide by this 3 since I multiplied by 3 to get those factors. X -1/3, I can't simplify 1/3, so I'm going to bring that bottom up. And I'm going to get 3x -1. X -6/3, I can simplify, because 6/3 is really 2. Bam. You want to see one more where they're both negative? Yes. So if you wanted to double check yourself, absolutely. So if you get to here and you're like, oh, did I pick the correct factors? Did I simplify correctly? All you have to do is go back in and FOIL it. So you say, okay, 3x times x gives us 3x squared. 3x times -2 gives you -6x, because -2 times 3 gives you -6, and then we bring the x along. -1 times x gives us -1x, and -1 times -2 gives us +2. Then we can collect our like terms. -6x minus 1x gives us -7x, and I just bring down my +2 and my 3x squared, and now I have exactly the same thing that I started with up here, so I know that my answer was correct. So you can always check yourself by busting out your foiling skills and actually foiling it to make sure that you have the correct signs if you weren't totally confident with yourself. Also, it would be a great, like if you were taking the SAT or the ACT and it was a multiple choice test and maybe you forgot how to factor, but they had 4 options for you, you could go in and foil them all and see which one gave you the actual answer, right? The test taking skill. Use the answers to find it. So let's do one more where they're both negative, and then we'll start your classwork. So now we've got 2x squared minus 5x minus 7. So again, we're going to take the 2 times the -7. So we do 2 times -7. 2 times -7 is going to give us -14. So now we need factors of -14 that add to -5. So since we want factors of a negative number, that means one of them's positive, one of them's negative. Since we want them to add to be a negative number, that means the bigger factor has to be negative. So I have 1 and -14, or 2 and -7. I don't have to consider -1 and +14 because that's going to add to be a positive number. And I know I need a negative, so I can cross those off right from the beginning. So then I have to look at those 2 options and say, okay, which one gives me 5? Which one gives me -5 if I add them together? And I see if I take 2 and I subtract 7, I get -5. So then my parentheses are going to be x plus 2, x minus 7. And then I've got to divide by this 2 before I'm done. So I divide both of them by 2. 2 divided by 2 is going to give me 1, so my first set of parentheses I can just write x plus 1. 7 divided by 2 doesn't work, right? It gives us a decimal, so that's where we're going to bring our bottom up. So we end up with 2x minus 7. So anytime that you have a coefficient out in front of that x squared, you should be bringing the bottom up in at least one set of the parentheses. You should never, your final answer should never have x's by themselves, because if you just have x's by yourself in your final answer, you're going to multiply to just get x squared, and you won't get that number back that's out in front. It is possible that both of them won't simplify, and they could both end up with numbers in front of the x. So that is possible. But you should at least always have one if there was a number in front of your x squared to begin with.